Okay, in this second video, we're going to look at finding the equation of a cubic function when we are given the graph. So I'm going to look at two different questions here. The first question I'm going to look at is page 405, question 4, part D. So in question 4, part D, we are given the graph that looks something like this. We have the information that it touches the x-axis at -3, it crosses the y-axis at -18, and it crosses the x-axis at 4. So the basic information we can gather from this is that, first of all, our roots are x equals -3, repeated root at x equals -3 because it is a turning point on the x-axis, and our third root is x is equal to 4. So turning these into factors, we have the following factors: x plus 3, x plus 3 by x minus 4. So that's our first step. So from this diagram, we can see clearly that it touches the x-axis at -3, crosses the x-axis at 4. Therefore, we have our three roots of the function, and now we need to multiply them out. So we take the first two brackets first. X plus 3 by x plus 3 is x squared plus 6x plus 9. And then multiplying it by x minus 4. Now you can do this step by step if you like. So x squared by x is x cubed. X squared by -4 is -4x squared. We have plus 6x squared minus 24x plus 9x and then minus 36. So the next thing we need to do is tidy it up. So we have x cubed minus 4x squared plus 6x squared is plus 2x squared, minus 24x plus 9x is minus 15x, and minus 36. Now the one problem with this function is that it does not cross the y-axis at -18, it crosses the y-axis at -36. So we need to multiply it by a number which makes sure, so the missing number here is the a, and we need to figure out what that is in order to bring our y-intercept back to -18. So looking at the relationship between the two, we need to half this number here. We want to retain the negative sign, but we want to half it. So we multiply the entire function by a half. So our true equation of our function is a half x cubed plus 1x squared minus 15 over 2x minus 18, and that would be the true equation of our function. So always make sure that you complete that last step and making sure that you find out the value of the a in front of the x cubed. So that is a fairly straightforward question. The other type of question that we can get here, I'm going to skip forwards to question number 9 on page 406. So in question number 9, we are again given a graph, but we are given less information. So the graph that we are given looks like this. So we are given the coordinates of this point here, -1. We are told that our function crosses the y-axis here, but we're not given the coordinates. And we are also given a linear function . Tidy up my diagram there. So we're also given a linear function gx that intersects the cubic function at the points b and a. So we are told that our cubic function f of x, which is this one here, is px cubed plus qx minus 2, and our linear function gx is x minus 2. So we are asked to find three things. We are asked to find a, the coordinates of point A, b, the value of the letters p and q in our cubic function, and c, the coordinates of point B. So let's look at point A first of all. Now we know that the linear function crosses the x-axis at this point. We have the entire function of the linear function, so in order to find a, all we need to do is find out where on this linear function does y equal 0. So therefore we are looking at 0 is equal to x minus 2, which means that x is equal to 2. And therefore the coordinates of point A are 2, 0. So given this information now, it's fairly easy to find the value of p and q, because we know that our f of x, our cubic function, is px cubed plus qx minus 2. We now know that we have the 3 roots of the cubic function, so we're looking at, for part B, x equals minus 1, which is a factor of x plus 1. This is a repeated root, as the maximum turning point occurs on the x-axis at minus 1. And our third root is x equals 2, so therefore the factor is x minus 2. So we did the same procedure as before. We multiply this out. So multiplying out our first 2 brackets first, we have x squared plus 2x plus 1. And then multiplying that by our x minus 2, we get x cubed. We have plus 2x squared minus 2x squared, which eliminates. We have minus 4x and plus 1x, which is minus 3x, and we have minus 2 at the end. So you can do it out step by step as I did in the previous example if you find it easier, or if you can skip straight forwards to this line, absolutely perfect. Just be careful with your multiplication. Now, checking that it does in fact cross the y-axis at the correct point. We look at here, our function fx is px cubed plus qx minus 2. The minus 2 is matching, so therefore we know that p is equal to 1 and q is equal to minus 3. So we've solved that. The last thing we need to do is find the coordinates of b. So b is the intersection point between the cubic function f of x and the linear function g of x. So in order to find this, all we need to do is solve them. So I'm just going to write my values here so we don't forget. So solving them, we can let them equal to each other. So we want to know, when does f of x equal g of x? So that means we have x cubed minus 3x minus 2 is equal to x minus 2. Bringing everything to one side, we have x cubed minus 3x minus x is minus 4x. Minus 2 plus 2 is 0, so we have x cubed minus 4x is equal to 0. We can factorize out the x, which leaves x squared minus 4, which is the difference of 2 squares, so we have x minus 2 by x plus 2. So therefore our 3 intersection points occur at the coordinates x equals 0, x equals 2, and x equals minus 2. A occurs at the point x equals 2. This point here on the y-axis occurs when x equals 0. So for b, we are concentrating on the x value, x is equal to minus 2. To get the equivalent y value, we can substitute into either of f of x or gx. Gx is probably easier, it's simply x minus 2. So y is equal to minus 2, which is minus 4. So therefore the coordinates of b are minus 2, minus 4. So based on these 2 videos, I would like you to do the questions in exercise 11 on pages 405 to 407. And if you have any questions, please let me know. Thank you.